Well, thank you very much for having me. It's a real honor to be here, and it's a real honor to be part of this group from CMU, who is doing such groundbreaking work in the field of artificial intelligence. So I'd like to talk a little bit today about the sort of blend of artificial intelligence and machine learning for product design in particular. Because while Stefan talked about how artificial intelligence can be used on the factory floor to rethink what a factory can do, we at Citrine think about artificial intelligence in the step that precedes that, which is how do we design better products? How do we design more performant products? How do we manufacture those products more efficiently, but with a focus purely on the product, not on the sort of factory infrastructure around that product? So the first thing I'd like to assert is that artificial intelligence is going to fundamentally change how we develop products, not just the steps by which we develop products. And so I think Stefan said it very well when he mentioned that the factory is going to look very different. The phases of the life cycle of a factory are going to look very different. And it is my assertion that we are going to see something very similar in the world of product design, where for a long time you had a list of materials provided by a number of providers. You know, you have your Alcoas and your 3Ms and your Dows and your DuPonts who provide you a list of the things you can make a product from. And then you have a designer at a Ford or a GM or a GE or a Boeing who then looks at that list and says, now I'm going to design parts from these materials. And then you then take those designs and you merge them with materials, and then you then carry them into the manufacturing space. And the way the world is going to change and the way artificial intelligence is going to change how we do things is that you're not going to see these things separate anymore. And indeed, this is what we do at Citrine. We take information about the materials we have today, so the things that limit our products. How many people in here have a smartphone? How many people in here think the battery lasts long enough in their smartphone? Wow, I think we found the one point of agreement in the entire face of the planet here. The battery problems that we have in smartphones are materials problems. It's a question of how many times can you cycle that material. And so rather than saying we're going to solve a materials problem, and then we're going to try to assemble those materials into a battery, and then we're going to test it, what we say at Citrine is that we need to, it's okay, you can, don't worry about it. What we say at Citrine is we're going to design the material and the part together. And I can give a bit more of an extreme example because I think performance is really where the opportunity is for us in this field. It's blinking at me. SpaceX is I think many people are familiar with SpaceX. SpaceX printed the first flew the first 3D printed thrust chamber a couple of years ago on one of their test devices. So it was a 3D printed rocket nozzle that was able to achieve performance that heretofore was unachievable because they were able to achieve new geometry and material combinations that weren't available before. And that's really cool, because if we think about all of the things that we want to do as a society, we want to make things greener, more efficient, higher performance. If we want to do all of these things, we need to do so in a way that still allows us to create the products we want. And so what artificial intelligence allows you to do is bring together information about what's available to us today and optimize the design pathway for a new product to create that next generation space vehicle. And the best part about it from a policy perspective is that we as Americans have an opportunity to leap ahead of what is out there today in any other economy, because we have the artificial intelligence expertise where we can actually start to merge these design cycles into manufacturing, we can merge them into product design, we can merge them all the way back into materials. And we have seen this. I had the opportunity to work with a professor at University of California, Santa Barbara, to actually invent a totally new type of 3D printing alloy for those aerospace applications. So we're doing this today. Artificial intelligence has arrived. And so the question, though, is how do we accelerate this? How do we accelerate the opportunity for American manufacturing to actually take advantage of these artificial intelligence technologies? And if you ask artificial intelligence experts across every field, but particularly in these data-constrained fields, the answer is always the availability of data. And so for all the folks here that are involved in manufacturing in one way or another, which I assume is mostly everyone, we have an opportunity as a country here to create national policy where we can actually bring materials and manufacturing data forward. I've heard from national lab leaders, I've heard from funding agencies, I've heard from military agencies that we need to hear from Congress that data sharing and data policy is something that we care about. And I'm here to tell you today that without that policy, we are going to fall behind in artificial intelligence for product design and manufacturing. And so this is a huge opportunity for us to help us maintain our lead in this field. And it's something that's we've taken some baby steps towards. The ARM Institute, recently established at CMU, is a great opportunity for us to convene this type of manufacturing data together. There's an additive manufacturing institute at Colorado School of Mines that has done the same thing. And so there are opportunities to do this, but on a national basis, we really need to understand how we're using this data, because for Stefan's applications, for mine, and for every other artificial intelligence technology, we really require good data to be available. And if we don't make moves now to do that, we are going to put ourselves at a disadvantage over the long term. So I'm really excited about where artificial intelligence is going for materials design, for product design, and for manufacturing. And on this slide, I actually did have some nice images, so you'll have to pretend that you're impressed. And I think there's a lot of opportunity here, and we in the US are in the driver's seat of these technologies. And so it's incumbent upon us to take the policy actions that we can do to maintain that leadership position and really advance this hyper-advanced manufacturing that exists in the US today into much, much broader use within our own country to increase our exports and increase our product performance. So with that, I thank you.